Hello, we are Team Nimble and we took on Challenge 7B, Understanding and Predicting Designer Partner Performance. Team Nimble are John Jenkins, Andrew Dickinson, Casey Banks and Russell Willis. The problem statement. Building contractors CISC want to assess the relative performance of different designer partners through metrics derived from their ViewPoint design data. There are very few established tools available to project teams to allow easy and clear monitoring of performance of the design teams, despite a large amount of design-related data being available. The user story from the viewpoint of CISC management. We want to meet the CEO of our main design partner to discuss concerns of their poor design management performance. We want to know how RFIs are distributed across the project period and whether we should invest in front-loading design efforts. Delving deeper into this user story, we might also want to predict when my design partners are heading into difficulty so that we can support them, to gain insights into those predicted difficulties so that we can target interventions, and to use our project data to develop meaningful KPIs to incentivize our design partners on future contracts. Two data sets were provided by CISC, RFI data and drawing data. RFI data, which are requests for information, where additional clarification and information is required on specific elements of the design. Whilst these are a normal part of the design process, it is thought that an excessive amount of RFIs indicates a design is badly thought out or incomplete. Drawing data, which consists of schedules, general arrangements, layouts, and drawings representative of the type of drawing that all projects will likely have. The key focus of this data is on revisions. An excessive amount of revisions indicate a poorly coordinated drawing. Data processing. On first review, we felt that the data was reasonably robust. There weren't a lot of missing values and it seemed relatively clean. On closer inspection, we found some idiosyncrasies introduced by the way that the system recorded its data. For example, when an RFI was marked as closed, that state replicated through all the records for that RFI, so we were unable to tell which revision of RFI addressed the issue at hand. It also noted that the data as presented reflected when administrative action was taken, i.e. when the system was updated, as opposed to perhaps when the real-life action was taken on the project. The main processing was undertaken using pandas in a Jupyter notebook. Mostly this was data aggregations such as calculating columns for the number of revisions and RFIs went through, and assumed project milestone dates such as start and finish dates. It was noted that the revision history of an RFI was considerably easier to process than that of a drawing. Our solution is a Power BI dashboard. A screenshot of it is here, and the main executive summary would be the league of poor performance, where the CEO can look at maybe the top 5 or 10 design partners ranked on a performance metric we developed. Then we also have bubble charts, which give a visual indication of where RFIs might be presented later in the design phase and therefore contributing to worse project performance. Further metrics we could display in drill-throughs include counts of RFIs created per month and close times, and we can provide detailed analysis to suit the project manager's requirements. Machine learning model. A predictive element to this challenge was included as a proof of concept or a view to where we could see this challenge going in the future. The investigation was relatively successful. Focusing on the RFI data in this instance, we developed a model to predict whether an RFI would be closed in an above or below average number of revisions. The model utilized logistic regression and had a predictive accuracy of 70%. Machine learning model continued. The model as discussed would allow a project manager to take preemptive action for an RFI were it to be predicted that it was going to cause issues within the project. This will lead to improved project performance as the program can be adjusted proactively instead of reactively. Commercial applications. In use of the tools, CISC can develop a supply chain performance league table and foster partners of choice. Ultimately, it becomes a tool to judge value for money in the design space and perhaps also lead to developing adjustment factors on initial designer quotations. The key benefits to CISC from this tool will be in taking the insights and developing focused KPIs to measure designer performance, linking to commercial benefits, for example, fee plus performance bonuses. Using the drill-through pages on the dashboard and our machine learning predictions, CISC can conduct focused interventions on projects heading for some inflection point on the project performance in advance of any large impacts. CISC can use the league table to identify star performers, both by designers and high-performing projects, and a lot of designer behaviors are driven by projects and end client culture. Things to do. Time is limited on our project hacks and many things fell outside of our ability to complete before the deadline. For example, stitching the various Power BI workbooks together to create working drill throughs. This is a simple task that could be completed inside of another half day. We also wanted to extend the machine learning code to bridge across both RFI and drawing data for a more complete forecast. For further development, SIS could provide some supporting data as presented in this slide. Judges' questions. What additional benefit could you have got by combining the RFI data from the other challenges? Could we develop this for the next hack? RFI metrics from multiple construction companies will highlight common themes and promote collaborative sector-wide conversations. This will encourage the sharing of best practice and design management. Pooling similar data from design companies are a critical component of the overall industry challenge and shouldn't be ignored. It's a two-way story with many influencing factors. RFIs often flow upstream to end clients, especially at the design stage. Bringing in these data sets would help to stitch the full picture together. However, caution on making the tool too bloated. Combining the data could lead to improved accuracy of our predictive models. The next hack, bringing RFI data from designers whilst making the model more complex and multifaceted, could enable a future hack to build drill-through insights. We need to encourage a full 360 performance reviews between contractors, designers, and clients. We'd like to develop a user interface for the machine learning model at the next hack to improve ease of use and remove the requirements of coding experience to interact with the model. What metrics have you used to be able to quantify RFI designer performance on a project? We developed a performance metric which brought together the number of RFIs and the number of drawing revisions for each designer and for every project. We developed some machine learning code to predict future performance. It looked for key features across many metrics to predict a future performance metric. How would I use the information to incentivize a design company? How would I manage them differently as a consequence of your analysis? Incentivization can be developed in the form of contract clauses. For example, fee could include a component linked to KPIs. Regular 360 performance reviews encourage two-way feedback at a business-to-business level. Perhaps these CISCs might gain insights on how they could better support the management and coordination of designers. We have benchmarked the expected level of performance, allowing us to be informed when having consequential discussions with designers. On changing or adjusting the management of designers, CISC could introduce staged design assurance throughout the pre-construction phase. Assurance reviews will cover maturity of design, planned versus actual, staged assurance that designs are progressively meeting project requirements, interdependency checks between different designers, and information flow and constructability reviews.